Okay, so let's solve this question. The question states that the functional dependency f from x to y is termed as useful functional dependency. So this useful part is being defined in the question if and only if it satisfies all the following three conditions. First is that your x, this x, is not an empty set. Okay, so x is not equals to phi. Y is not an empty set. Okay, so y is also not equals to phi. Intersection of x and y is an empty set. Okay, so x intersection y is equals to phi. This part is also there. For a relation R with 4 attributes, the total number of possible useful function dependencies is, first of all, this 4 attributes. This attribute over here reflects the total number of columns, right? Columns that are present inside of a relation, that is a table in your relational model, right? So that table having number of columns is what is referred to as attributes. This number n is also termed by arity and degree in DBMS, right? So that if the question had used a different word, you may also know it, right? So total number of possible useful functional dependencies. Okay, so we are given that 4 attributes are present and we have to find in how many ways, given these conditions that neither x can be, this is a functional dependency, right, from x to y. So their conditions are that this cannot be phi, this cannot be phi, and this cannot be phi, right? Also, the intersection of x intersection y must be equal to phi. These three conditions being present, what are the total number of ways in which you can take these attributes? This a and b can be come to the left hand side, and this c and d could go to the right hand side, like this, right? How many ways can you arrange it so that you can get useful functional dependencies from this information? This question originally is from DBMS because you must know the terms to form the mathematical model, but once that part is done, it is genuinely a combinatorics question that you must solve, right? So let's take that, right? So these are the conditions. This is the functional dependency from x to y, right? From x to y, and these are the 4 attributes, right? So let's try to imagine how many ways can I take this. I can take 1 attribute on the left hand side and I can take 3 attributes on the right hand side. Wait a minute, why did it not come there? Okay, no problems. So this is B, this is C, and this is D. Mind you, one more part, that if I were not to take D over here, then also this is a valid entry because the conditions are met, because left hand side is not empty, right hand side is not empty, and the intersection of both, right, the left hand side and the right hand side must be mutually exclusive. The intersection is equal to phi. All these conditions are met, right? So for only a single element being present, we can have either 1, 2 or 3 number of attributes on the right hand side, right? So let's, for convenience, assume that the small alphabet x and y reflects the number of attributes that are present on the left and the right. Okay, now with this being present, there are possibilities. We are basically classifying what all possibilities we have to consider, right? So for x being 1, the right hand side could basically be 3, the right hand side could also be 2, the right hand side could also be 1, but the right hand side could not be empty because that is a fundamental condition that the left and right are not empty, right? That part is clear. Now if we were to take one of the elements over here to the left hand side, so the left hand side has 2 elements, right? These could be any one of these 2 elements. I know that part we will consider, but we are categorizing the whole situation so that we can get to a comprehensive answer and do not miss out any scenario, right? I know this one over here is very easy to say, okay, now we have considered all, but this one reflects that we have taken 1 from what? The original set, and the original set has 4. So this one over here represents taking 1 out of 4. That is what we will finally formulate when we are trying to find the expression to find the answer, right? Now the left hand side has 2, the right hand side could have 2 and could also have 1, right, from a numbers point of view. Okay, let's do that. So 2 comma 2 is a correct set of numbers for x and y. 2 comma 1 is also correct set of numbers. Now for 1, the right hand side could have, sorry, what am I even doing? The left hand side being equal to 3, the right hand side is going to have only a single element, right? Why? Because this c, once taken on the left hand side, the right hand side is left with only a single element, right? Now this 2 has been selected out of 3. This is one important thing, right? This 2 has been selected out of 3 and this 1 has been selected out of the original 3. Likewise, this 1 has been selected out of the original 2. This is something that you must understand, because when both of these were on the right hand side, we could have taken any one of these, anyone, B or C, and then taken it to the left hand side to achieve this 2, right? So this 2 has been taken from the 3, not the other way around, right? Now this 2 and 2 and 2 and 1, once all these things are very clear, I am going to basically show. As I said, this 1 has been taken from the original 4, right? So from a combinations point of view, it is 4C1. I do hope that permutation combination, that part you already know. If you don't, please go and watch some videos on that, because it is very fundamental if you want to solve questions regarding combinatorics, fundamental ABCD of that, right? So 4C1 times this 3, from this 3 we are picking 3 over here. For this 2 we are picking 3C2. Likewise, for this 1 we are picking 3C1, right? Once this part is done, this whole row is done. Now these possibilities we are going to consider. We are going to add 4C2. In that I am going to add 2C2 plus 2C1. Okay. Likewise, for the last one, 4C3 times what? 1C1, because this is only 1 now, because from 1 we are picking 1. This is obviously 1, right? Once this is the expression we are going to require to find the answer. Okay, so I can directly solve them, but as you can see, a lot of combinations have to be solved for this, right? One more simplification that you can do over here, which is quite evident to any person who has practiced solving these kind of questions in recent time, is binomial theorem. It states that for nc0 plus nc1 plus nc2 plus till ncn is equals to your 2 raised to the power of n, and this part nc0 is equals to 1, right? As you can see, this whole part reflects the kind of pattern that is present right over here and also right over here. These are reflections of this pattern, because why? 3C1, 3C2, 3C3, 3C0 is missing over here. That is what I am trying to say, right? So just do that. Just add a 1 and subtract a 1. What will you get? Add a 1, that is add a 3C0, right? Add a 3C0 and subtract a 1, because this thing is equals to 1. Likewise, do over here also. Once you do that, you can directly see that this whole part is nothing but 2 raised to the power of 3 minus 1. This whole part is nothing but 2 raised to the power of 2 minus 1. A lot of simplification. You don't need to solve for a lot of combinations if you do it this way, right? So let's do that. What do we get? 4C1, what am I even doing? 4C1 times 2 raised to the power of 3 minus 1 plus 4C2 2 raised to the power of 2 minus 1 plus 4C3, and then this last part I am not applying it over here. This is 1C1, that is equal to 1 only. Okay, then what? 4C1 is basically 4 times 8 minus 1 plus 4C2 is going to give us what? 4 times 3 by 2, that is 2 times 3 is going to give us 6 times 3, because 4 minus 1 is 3, plus 4 times 3 times 2 by 3 times 2 is 4 times 1. Okay, so let's directly add it. So 4 times 7 plus 18 plus 4, What does this thing give us? 18 plus 4 is 22. This thing is 28. 28 plus 22 is going to be our answer. So 28 plus 22, answer is equals to 8 plus 2 is 0, 1. 2 plus 2, 4 plus 1, 5. Right? So 50 is going to be our answer. I do hope that you were able to follow what I am trying to teach, because this was a 2-mark question, I know, but it was a simple direct question if your basic funda and concepts are clear, right? And I do hope that you must have been able to solve it by yourself. This is only a validation video. You must be able to solve it by yourself and only watch solution videos after that, right? And I will see you in the next video. Thank you.